Alright, Mr. LaHaye here, Unit 10 review for geometry. Here we go. I'm going to do 2 pages at a time for this one because it is such a long review. Alright, number 1, we need to solve for WZ and then XZ. First thing we have to do is label what's given. So I'm going to go ahead and do that. Alright, so you can see now that I know the small length of this side and the big length of the top side, so I'm going to use that for half of my proportion. So to solve for WZ, I'm going to say 8 over 16.8, small over big, equals the small version of WZ, which is VY, 7 over WZ. Alright, little cross multiplication. 16.8 times 7 and then divide by 8 gives you an answer of 14.7. For part B, same thing. I'll label that A. For part B, I'm still going to use 8 over 16.8 as my reference because I know both parts. Now I know XY and I want XZ, so small over big. Same thing, 16.8 times 6 divided by 8 gives me an answer of 12.6. And number 2, very much the same concept. I'm going to label what they give me here. 8, 18.4, 4, and 5. Now my reference side is going to be 8 over 18.4. I want WZ, so 8 over 18.4 equals 5 over WZ. Cross multiply 18.4 times 5 divided by 8 gives me an answer of 11.5 for part A. For part B, I'm still going to use 8 over 18.4, only now it equals 4 over XZ. And again, 18.4 times 4 divided by 8 gives me 9.2 here. And number 3, I'm going to go ahead and label here. I've got the entire side MP is 13, this is 7, this is 8, this is 11. You should be able to recognize that this coincides with this, so my reference side is 8 over 11. First I want PQ, that's the small version of 13, so I'm going to say 8 over 11 equals QP over 13. Again, small over large equals small over large. Cross multiply, divide by 11 gives me 9.45 is my answer for part A. For part B, I'm still going to use 8 over 11, small over big, only over here I want ON, so this is a little bit more complicated. Actually, there's many ways to do this. The way that I'm going to go ahead and do this part is I'm going to say, okay, 7 over PN. Okay, so I've got small over big equals small over big. I'm going to solve for PN. I get 77 divided by 8, which is 9.625. But then I have to subtract, I only want from O to N, so I need to subtract out this 7. This is the whole thing. I have to subtract out 7, so the answer is 2.625 for number 3. Number 4, is this a parallelogram? We went over this in class. I just need to make sure of proportionality here. If you do work through it, this is 25 and this is 15. Again, you can relate triangles back to the whole. I'll just show part of it right here. If I have triangle ABC, I'm going to separate it. Find the length of the sides, you get 72, 40, and 40. So I'm going to look at that right there without using proportions and say this is an isosceles triangle. Well, if this is an isosceles triangle, then this must be an isosceles triangle. Okay, so there's a lot of different ways to do it, but basically 27 over 72, 15 over 40, and 15 over 40, they're all equivalent, so you're good there. Same thing over here, it's got to be isosceles, so this has to be 25, and it is, so you say yes, by showing that proportionality. I'm going to attack number 5 a slightly different way. Here's my concepts for number 5, because your overall triangle here for number 5 is A, B, C, and now I'm going to get the lengths. This would be 40, this would be 72, and this bottom is now 15 plus 20, which is 35. So, same thing as before. If this is a parallelogram, These have to be both 25, opposite sides are congruent, and 15 and 15 have to be congruent. So I'm going to take this first triangle on first things first here. So I want this triangle. I'm going to compare it to the big triangle because they need to be proportional. So I've got 15, I don't know this, and this is 27. So I'm just going to choose two sides here. I'm going to say 40 over 15 equals 35 over x. And now I'm going to cross multiply. 15 times 35 is 525. That equals 40 times x. When I divide that by 40, I get 13.25. X equals 13.125. If this is 13.125, that means that this and this are no longer parallel because they're not the same length, so this one is no. And the y or y not is shown by the proportion. Number 6. If these lines are parallel, then once again you've got proportionality in their triangles. If I separate the triangles, I've got one with a 5 and one with a 6, and then the large triangle has a side length of 15 and 18. When we set up proportionality, 5 over 15 and 6 over 18, they're both equivalent to 1/3, so you say yes. Sides are proportional. Number 7, figure at the right, we go ahead and we, first of all, you should recognize vertical angles. Get those out of the way first. AE is 3, CE is 8, EB is 12, and DE is 5. Now before we just rattle off an SAS, we have to check for proportionality. The small side from each triangle, 3 and 8, 3 over 8, and the large side, 5 over 12. If you check them, this is 0.375, and this is 0.416 repeating. They're not proportional, therefore this is no. Justify your answer would be by showing that work right there. Finally, number 8, same thing as before. You've got the angles that are congruent. You need to recognize those by vertical angles. If we label, we've got 32, AE is 24, EB is 48, and I told you this was a typo. This should be CE equals 36. And now we're going to check for proportionality. I'll go big side, 48 over 32, the longer side from each respective triangle, and 36 over 24. If you check this, this is 1.5, and this is 1.5. They're proportional. So you say yes by SAS, side, angle, side. You check the proportionality. You're good to go there for that one. That is page 1.